C2, Differentiation Example 4. So here we're asked to find the stationary points on the curve y equals 3x to the power of 5 minus 5x to the power of 3 and determine their nature. So again, we need to remember what this term stationary point means. So a stationary point is where dy by dx equals 0. So we need to find all these points from this curve and determine their nature. So the first thing we need to do is actually find dy by dx. So when we differentiate, we multiply by the power and reduce the power by 1. And again, multiply by the power and reduce the power by 1. So we want to find where 15x to the power of 4 minus 15x squared equals 0. Well, that's going to be the same as where x to the power of 4 minus x squared equals 0. So we can take x squared out, and we'll have x squared minus 1 equals 0, which gives us 3 stationary points, x squared, x minus 1, x plus 1 equals 0. So we'll have x equals 0, or x equals 1, or x equals minus 1. So we need to find the y values at each of these points. So if we have 3 lots of 0 to the power of 5 minus 5 lots of 0 to the power of 3, we will have y equals 0. And when we have x equals 1, we'll have 3 minus 5, which gives us a y value of minus 2. And we have x equals minus 1, we'll have minus 3 plus 5, which would give us y equals 2. So that's just substituting each of the x values into the original equation that we're given at the top there. So we need to find the gradient at either side of these points to determine their nature. So the first thing to do is to have a look at the left-hand side of x equals 0. So the left-hand side of x equals 0 will be x equals minus 0.1. So substituting x equals minus 0.1 into this equation here will give us a dy by dx equal to minus 0.1485. Okay, now we need to test the right hand side of x equals 0, and that'll be x equals 0.1. And that again, if we substitute x equals 0.1 into this, we come out with minus 0.1485. So because each side of x equals 0 have the same nature of gradient, which is negative, we know that at x equals 0, y equals 0, which is the coordinates 0, 0, we have a point of inflection, which you would expect because we have an x squared, which is a repeated root. So now we want to have a look at x equals 1. So we'll have a look at the left-hand side of x equals 1, and that would be x equals 0.9. So when x equals 0.9, we get a gradient, obviously putting it back into this 15x to the power of 4 minus 15x squared, we get a gradient of minus 2.3085. So now we need to have a look at the right-hand side of x equals 1, which would be x equals 1.1. And substituting this into 15x to the power of 4 minus 15x squared will give us the gradient 3.8115. So because we go from a negative gradient to a positive gradient, we know that at 1 minus 2, we have a minimum. And now, again, for the third point, the left-hand side of x equals minus 1, which would be x equals minus 0.9. Sorry, that would be x equals minus 1.1. Substituting x equals minus 1.1 into 15x to the power of 4 minus 15x squared will give us the gradient 3.8115. And then testing the right hand side of x equals minus 1, which you substitute in x equals 0.9 now, minus 0.9 now. Substituting that into the equation for the gradient gives us a gradient of minus 2.3085. So because we go from a positive gradient to a negative gradient, we know that at minus 1, 2, we have a maximum. Now it doesn't ask you to draw a graph, it just says to determine the stationary points and their gradients, but from the information that we have here, I'm just going to draw you a quick sketch. So the line of the curve will look something like this, with of course your points on, so this would be at minus 1, 2, where our maximum is, and then we have 0, 0, where our point of inflection is, and we have 1, minus 2 here, where our minimum is. So you don't have to draw the curve, but this is just showing what we have found from finding the stationary points.